Looking at the problem right away, it's a question where you have to choose the option related to the angle of incidence at which the ultrasound beam enters. If you look at the content, option C, which is the specular reflector, is a change that can be observed when the beam is incident perpendicularly, that is, at normal incidence. On the other hand, keywords related to scattering indicate that it occurs regardless of the angle, that is, it happens regardless of the angle of incidence. To summarize the question again, option C, which is the specular reflector, is associated with the angle in this way. For options A, B, D, and E, which are related to scattering, remember that they are characterized by the fact that they are not associated with the angle. So, you can organize the questions focusing on the keywords that are related. Moving on, let's look at question 72. If you look at the question, you can see the term testicular cyst. You can infer that an ultrasound examination was performed on a man's testicles. Among these, this question is asking about what kind of changes are observed in the hyperechoic area seen behind the cyst. If you were to describe this hyperechoic area in technical terms, the correct answer would be acoustic enhancement. In Korean, this is referred to as posterior acoustic enhancement, which you can summarize as the phenomenon where the area behind the cyst appears brighter. The next question asks about the cause of this phenomenon. Let's take a look at the main text right away. This is a question where you need to choose the sentence that best explains the hyperechoic area observed behind the cyst. The correct answer would be option B. To briefly explain with a diagram, you can think of cystic structures as allowing the ultrasound beam to pass through more easily compared to the surrounding soft tissues. As a result, posterior acoustic enhancement can be observed compared to the surrounding area. The fact that the ultrasound beam passes through easily can also be described as less attenuation occurring. If you look at the sentence, attenuation decreases, and when the beam passes through a fluid-filled structure, there is less attenuation, so a bright area like this can be seen. That's how I can explain it. Next, let's move on and look at question number 74. Since this is a basic topic, let's find the answer right away. When a lower frequency is applied, it allows for better depiction of deeper areas in liver imaging, so it has the advantage of less attenuation occurring. However, there is something called a trade-off. Just like a seesaw, when one side goes up, the other side goes down. This is what we call the concept of a trade-off. While it has the advantage of better penetration, on the other hand, as in option S, it has the drawback of reduced spatial resolution. So, compared to using high frequencies, when you use low frequencies for examination, there is the drawback of reduced spatial resolution. But on the other hand, the advantage is that it penetrates deeper. That's how I can explain it. Since this concept is called a trade-off, it would be good to remember the term as well. Moving on, let's look at question number 75. This question was also covered in the previous lecture. If you read the sentence carefully, you'll find it's a pattern you can solve easily. There's a term called normal incidence used in ultrasound examinations. It was performed with vertical incidence, and the key point is this sentence stating that there is no change in acoustic impedance. If vertical incidence occurs, but there is no difference in acoustic impedance, then there would be no mechanism for reflection to occur. In that case, we can explain again that all the beams are transmitted. So, the key point is that if you can interpret what it means for there to be no difference in acoustic impedance, you'll find this question easy to solve. Looking at the correct answer, we can choose option D. Reflection does not occur. Just remember once again that this concept is related to the difference in acoustic impedance. Moving on, let's look at question 76. There are two factors that determine acoustic impedance. Specifically, density and the propagation speed of the medium determine acoustic impedance. Let's check the correct answer right away and move on. Question 77 is important. Not only does it cover basic physical concepts, but it also often includes parts about adjusting actual equipment. You can consider this a representative question on that topic. Attenuation of the sound beam occurs, and as you go deeper, the penetration power of the ultrasound beam decreases, so naturally, attenuation appears. When this kind of situation arises, the question is asking about the system controls used to manage it. To compensate for the effects of depth, you can use TGC to address these issues. So keep in mind through this question that the study of physics also includes practical equipment control concepts. Now let's move on and look at question 78. At first glance, this problem might seem a bit difficult, but what it's actually asking is quite simple. It's a question about identifying the reason why diagnosing the brain of an adult with ultrasound is limited. In the case of a young fetus, since the skull hasn't developed, it's possible to observe the inside of the brain tissue using ultrasound equipment. On the other hand, in adults, since the skull is fully developed, there is a significant difference in acoustic impedance at this part, causing much of the ultrasound beam to be reflected before it can enter. You can find a sentence summarizing this information in option 2. Therefore, a severe acoustic impedance mismatch occurs between the cranium and the soft tissue. As a result, many of the beams are reflected, making it impossible to create an image. This is how you can summarize it. So, please remember through this question that when you express the concepts you already know in more physical terms, terms like acoustic impedance difference can be applied. Let's move on and look at the next question. Looking at the question, it asks you to choose the option related to diffuse reflection. The expression here can be understood as a concept similar to scattering. In the case of specular reflection, it depends on the angle due to perpendicular incidence, whereas scattering is characterized by spreading in various directions regardless of the angle. So, the correct answer would be option A. You can think of this kind of scattering in various directions as being referred to as diffuse reflection. Also, keep in mind that in typical exams, these two concepts are not strictly separated, and the term scattering is used more frequently. Let's move on and look at the next question. Looking at question 80, according to Snell's law, you need to select one additional option along with the angle of incidence. To put it simply, I explained in the previous lecture that Snell's law is related to refraction. In the question, the options related to angles are described. This is a question where you have to find one more answer. Along with the angle, the second concept was the difference in propagation speed. So if you look for the corresponding option, you can choose option D. In this way, it is related to the difference in speed between two media. Check that the correct answer is option D, and once again, make sure to review that Snell's law has this kind of connection. Alright, we've solved up to question 80 like this.